Well, good morning, everyone, and welcome to our yet another webinar, Teams Live event. And for today, we will be having steam trapping as our topic. And as usual, we will be having Nick presenting on this topic. And many of you are quite aware of him by now. It's quite Nick is quite experienced in the STEAM world with controls as a control specialist, and is currently even based in Nairobi, Kenya. And he will be taking us through the the webinar. And my name is Anthony Macharia with Cornelius, and we will be your producers for this live event team. Okay, so can go next. So a bit of housekeeping. We will be just give me a moment. Just give me a moment. I'm having a difficulties. I'm having a bit of difficulties. Maybe Nick can be able, Cornelius can be able to take me through that.
Sure, yes.
Yes, so
We're expecting this to be approximately an hour and everyone's mics will be muted. There is a Q&A section on the right-hand side of the screen, as you can see. So as we're going along, if you have any questions, please don't hesitate to pop them into that little question section. We will then either publish them into the main group or we will just answer them privately if we can. If there are any questions afterwards that we didn't get to, during this webinar, we will reach out after the webinar and see if we can help you out with those queries. All right. Yep, and those are just the slides that's just showing where to start typing, and then once you're done, you hit post, and the post will come up, and we will monitor it on our side and publish it on the main group. All right. Over to Nick. Thank you.
Hi, how is everybody today? I hope everybody is well. My name's Nick. As introduced by Anthony, I work for Spirax Sarco. Been here a little while. I've been working for the company sort of over 7 years, so generally sort of occasionally know what I'm doing. So we're going to run through who Spirax Sarco are, just for any newcomers. Steam traps overview, selecting the correct steam trap, and steam trap checking. So first off, who is Spirax Sarco? So we were first founded in 1888 by Sanders and Reinders under the name Sanders and Reinders Co., which later formed the Sarco of our name. So it's the formation of both those. In 1932, we started manufacturing in the UK and we introduced that under a brand called Spirax. That then gave us the company name Spirax Sarco. We operate in 145 or over 145 companies, local sales offices, another 180, 55 countries served by our distributors, and over 10,400 employees with over 2,000 local service teams. We have 29 manufacturing sites, so 29 factories on 4 different continents. And our HQ is in a place called Cheltenham, which is on the southwest of the UK. We have 59 customer training sites worldwide as well. So under the Spirax Sarco group, we have companies where Steam Specialties, which is where Spirax Sarco falls. We own Gestra and Cotopaxi. Some of those names may be familiar to you. Our thermal electric solutions are covered by Chromalox and Thermalux, and Watson-Marlow is also owned by the group. We're a FTSE 100 company, turnover roughly £1.4 billion a year, and over 30,000 products. Some of the ranges we offer here, as you can see, are boiler control systems, clean steam valves, normal valves, humidification, isolation, compressed air, steam traps, pipe ancillaries, and our service offerings, depending on where you are in the world, is health and safety compliance, steam audits, quality testing, valve reconditioning, and so on. And we know what we're talking about. So this is one of our boilers. We are saying the UK. We operate, we test it, we train on it as well. So we actually use the products we sell. So how do steam traps work? So each steam trap is different depending on the installation and its usage. The idea is to clear condensate from steam so that your steam line stays as dry as possible. So the dryness factor is as good as possible. It tends to be about 95%. You need a difference in pressure, so a drop in pressure, a delta P across P1, P2 to be able to allow flow. So why do we need them? So as I just touched upon, the duty of a steam trap is to clear the condensate. It connects to the steam system so it doesn't allow any steam to escape and ensures that they stay separate. So it also prevents water hammer to maintain plant performance. So the drier your steam, the more enthalpy it has to give up, the less damage it does to equipment. So they're integral to your steam system. But they also, if you do not look after them, they can cause poor steam plant performance by making your steam wetter. There's more carryover in the pipe. It's more corrosion in the pipe. So they are, like I said, integral to the steam system. So as it says here, without the steam trap, we have no way of stopping the steam flowing straight from the process. So we need some way to be able to control the steam, but also keeping it dry enough to be able to use it. So as you can see here is an example. We've got a cooking vessel here, a pipe coming straight out, no trap. So you're losing steam, you're losing process. You're also clearing condensate, but it's a mixture of both. So we need some way to be able to keep the steam in there to transfer its heat, but also to remove the condensate after it's been condensed. So we put a trap set there. So as it shows here, we have the isolation valve, the trap, we have a sight glass here so we can tell the flow. It's collected effectively behind the trap and then discharged and sent back to ideally your feed water or your boiler, but reused somewhere. So condensate is allowed to form along the bottom of the steam pipe. This could lead to water hammer, so that's why we need to get rid of it, which could cause health and safety risks. So water hammer in a pipe, and we get to the next slide. So as you can see here, you've got condensate forming in the bottom of the pipe. As the steam runs over the top of the surface, there is a friction loss. So it picks up speed on the condensate. Eventually that forms a slug where there is no steam going through, but there's still this pressure here to be able to push forward. So you end up with a wave, a slug that ends up going down the pipe, and this can go at quite considerable speeds. So when that hits a bend or a closed valve or even a steam trap, it can do considerable damage. So we need to make sure that the condensate is as clear from the pipe as possible. Does anybody have any questions at this point?
None so far, Nick. So far, so good.
Okay, it might be shorter than I expected if we run through this quickly. So mechanical traps, we're going to cover the different types of traps and their usage. So the first one we're going to cover is the mechanical trap. This would, as it says there, will cover things like float traps and inverted buckets. Thermostatic traps will be covered next. These are balanced pressure biometallic element ones, and their usage and where we would best place them. And then we have the thermodynamic traps. So senses difference in velocity, which we will explain later, and uses that to clear. So these are kind of in order almost of capacity. So these will be the larger traps, which we'll also see. So these are for higher flow rates, higher condensate, and then dropping down to where you'd see main lines. So first, as I said, the mechanical. Got a video here, so I'm hoping it plays. I'm just trying to get to my pointer. There we go. So as you can see, as this runs, you've got condensate coming in on a vertical trap, filling the void, filling the space and raising the flow. That then opens the valve at the bottom. As the steam starts to fill the chamber, the ball drops and you end up with a kind of a middle position where the flow doesn't completely go down and close the orifice, but it raises and up and down as it's shown here and clears condensate. So the reason why flow traps are so useful is they are handy for clearing large quantities of condensate in process. So where we have an air vent, you have the orifice here. It allows you to clear the air, so you have no binding in your system, and the large volume, and it makes them perfect for things like end of lines where you're going to see the most condensate, machines that transfer a lot of condensate to them. So float steam traps, advantages: removes condensate as it forms. So effectively, it's as soon as it's there, it's got rid of. Accepts pressure and load fluctuations, so they're very good at dealing with changes in your process. Large discharge capacity, as we said already, and good air venting. So as we showed, there's an air vent on there which allows you to remove that. Disadvantages: it can freeze, probably not in Kenya or East Africa, but in other parts of the world. That can damage the ball. If you lose the integrity shape of the ball, it may not float, and if it doesn't float, the trap won't open. Any questions before we move on to bucket traps?
No questions yet on the mechanical traps. Thank you, Nick.
Okay. So again, we have another short video just to show the usage of a bucket trap. So this is, this is called an inverted bucket. So as you can see, you have the air being caught here, which raises and comes through the air piercing hole here and fills the void up here. As water comes in with no air, the bucket sinks, which opens the trap. And then you have steam, hot condensate coming in, which fills up. As it flashes off, it produces gas under the bucket, fills the void at the top, and slowly starts closing the trap. So the air hole, if I just go back to my pointer, is here. And as you can see, that's how it escapes and fills the area up here. These are very good for clearing large quantities of condensate again. They're not very susceptible to freezing because it doesn't really change the shape. It can, but most of the time it doesn't. Again, they are quite multi-purpose. They allow you to clear a lot of condensate quite quickly. So inverted bucket steam traps, these are some of the ways they will look. So as you can see, the advantages: removes condensate in all forms, just like the flow trap. They're robust, so as we said, they're not really affected by changes in weather, by freezing, by hot temperatures. Can be used for superheat, which is another advantage over the flow trap. The disadvantage, though, is they are very slow to vent air. They are open to air binding at times, can freeze, but they will and they can freeze. I've seen it in the UK and Europe. It doesn't do too much damage to the trap once it's defrosted. Like, any questions on bucket traps?
There is a question. The question is, what causes mechanical traps to fail in either a closed or an open position?
So it's generally either bad maintenance or water hammer, things like that in your system. So with the mechanical traps, with the float trap and the bucket trap, the only real damage you're going to see is by either freezing or by water hammer. So as we said, with the ball in a float trap, water hammer can squash the ball. It can change the shape of it. Then either pierces and sinks, so it doesn't open anymore. The bucket trap, not so susceptible to it, but equally with water hammer, it can change the shape of the bucket, and as soon as you lose the integral shape of the bucket, it won't work properly anymore. They are pretty robust. There's not much you can do to break them, but nothing in this world is unbreakable. I don't know if you want to add anything there, Cornelius, as well.
Yeah, just potentially the other thing, you'll notice one of those at the top has a strainer built in, so dirt also has a potential to go and sit on the seat, and then the trap doesn't close properly when it's supposed to. Another question has just come up, Nick, is is there any maintenance that you can do on these traps, the mechanical traps?
Yeah, of course. So us, as well as other manufacturers, we sell the spares for the for the traps. So it's not a case of having to replace the whole thing every single time. We replace what we have is a maintenance kit, so expected bits we believe will wear. But there's pretty much everything inside that trap you can buy and replace. As a general rule of thumb, this isn't always applicable, but most of the time, if you are buying spares for your steam traps, it's about 30% of the cost of buying a brand new item. So from a point of view of a cost point of view, it's much more effective for you to repair the traps you have than to buy new ones. Of course, everything has a shelf life. At some point, you will have to replace the whole trap, but they can go on for many, many years before you need to. Cornelius, when you're on site, I imagine you see the same schedule, so we would recommend at least these are inspected once a year, probably change of parts internally every 2 years. Mechanical parts with Spirex, I think they have a warranty of 2 years. Is that correct?
It's a 12-month warranty.
I thought that's on electrical. Mechanical, I thought it was 2 years.
I'm pretty sure it's 12 months.
So it may be slightly different in Europe, but yeah, it's
potentially, yeah.
Yeah, again, the cost is, like I was saying, is much more effective for spare parts than new parts.
Yeah. Look, I mean, the testing is an interesting one. How often do you have to test these things? I think it depends on the type of trap that you've got and the type of application that you've got. For critical applications, I'd say one could go to a more digital thing where we can add a diagnostic kit, a wireless diagnostic kit to a steam trap to at least indicate when the trap has failed closed. And that could continuously monitor the steam trap. And there's various other ways of doing it from a continuous point of view. And you can get a dashboard to actually help you understand what your trap population is doing. So, that is something that I think, again, as things like AI start taking over and as digitalization of plants become more prevalent, those are probably the things we'll start seeing into the future, where we can monitor online on a continuous basis what the traps are doing, and then send out a service team, where possible, to either go and repair or replace that steam trap.
So we will cover the digital offerings that we do as well later, just to show what Cornelius is speaking of. The other old-fashioned way as well is if you have a vent and you see steam coming out of it, you've got a problem with a trap somewhere. So general maintenance, preventative maintenance is always better than waiting till it's actually failed. But we have various different means of doing that. You can physically inspect them, you can
use digital signals to tell you if the traps have failed. There's many different options, and we'll cover some of them later as well.
All right, Nick, and then just another question has popped up. Kindly highlight the mode of installation for each.
Sorry, can you repeat that?
You highlight the mode of installation for each. I'm assuming this might mean vertical, horizontal, or whatever.
Yeah, so with the mechanical traps, not so much the bucket traps, but the flow traps, we do horizontal and vertical versions. So you can order either. It depends a lot on your installation and the space that you have. The inverted bucket traps, they always, not always, but the two models that we show there, so the one at the bottom, the one on the far right, they're both vertical mounted traps, and the horizontal one is the one on the left. So we do both. We do horizontal and vertical. It depends on what your requirement is, and we will work around you. Any other questions?
Okay, well, that one. Okay, we just answered that one now. The one about the installation, the mode of installation. So yeah, it depends on the trap, depends on the application, depends on the space available. We will generally recommend the correct trap.
Yeah. So yeah, we thought of that. We've had the challenges before, so yeah, both vertical and horizontal options are available. Okay. So thermostatic type traps. So these are the balanced pressure ones and the biometallic ones. So it senses a temperature difference between steam and condensate. So I'm just trying to make sure my video plays. So as you can see here, you have the condensate getting hotter coming in. It starts to expand the capsule at the top where the orange area is, that closes the ball. As the system cools, the expansion starts to contract. That lifts the ball and allows flow through the trap. So it's based on the relationship between the temperature relationship between steam and condensate, and it gives up heat, and ultimately the temperature of the condensate will fall. When the lower temperature is sensed, the trap will then pass condensate. So again, this is the capsule that's inside. So this is the area that expands. As it does, it pushes down the ball. These are a replaceable part. Obviously, because you have metal that is expanding, contracting, it has a lifespan, but it's a relatively simple thing to replace. So, and we show it there, it's closed. So as you can see, it's expanded. The ball has been placed back on the seat and closed the trap. So advantages to these is very good air venting, because when the system's cool enough, it's just an open trap. Wide pressure range, so these work on high pressures, low pressures, everything in between. Subcools condensate, which means that it holds it in kind of behind the trap a little bit. It's very good for things like heat tracing, where you're not going to return the condensate. You want to get as much heat out of it as possible because it's energy that you have paid for. So these have an advantage there. Reduces flash because it's subcooled, so there's less temperature range difference between the atmospheric or whatever pressure is down the pipe and the steam or the condensate you've just had. It's resistant to some superheat and water hammer. So it's resistant, yes, but it still has the ability to be affected by both. Superheat would effectively overexpand the capsule and can damage it eventually. Water hammer again, it's a pressure, and it's a large pressure from water hammer at times, so that can distort anything. And they're small, lightweight, so they're relatively easy to install at heights in small spaces. The disadvantages: waterlogging, if you're not allowed for, so if you haven't cleared that properly. and cooling leg required. So that, as we spoke, the length of pipe that's behind it to allow the subcooling of condensate. Do we have any questions on thermostatic steam traps?
Do we indeed? What is the best place to install a trap in a line that branches out to different areas?
So these particular ones are all traps. So
I think it's a general question.
So the best place. So the challenge we have is a lot of steam traps tend to be quite high because our steam lines tend to be quite high. If you can extend the pipe down to the trap to bring it down to ground level or somewhere nearer, it's more of a health and safety advantage. So if you don't need a crane, if you don't need any kind of lifting gear or apparatus to be able to service a trap, it also makes it easier for you to be able to physically inspect the lower it is. So these traps, with these, because you need the cooling leg, again, if you can drop it down close to the floor, if your main line is quite high, it makes it easier to view, but it also gives you that cooling leg because you have that length of pipe. It's very dependent on the trap. So things like the mechanical traps, they don't need a long length of pipe behind them. They work just fine straight off of the main, straight off of the equipment. These with cooling leg, they need some kind of distance. So we're talking maybe 1.5, maybe 2 meters of pipe. It's probably the maximum you'd really require there. But it depends on your usage. So these with the cooling leg, as I mentioned on heat tracing, it makes them perfect. So heat tracing tends to be dumped, not always, but a lot of the time, because of contamination. So you want that as cool as possible. You want as much heat removed from that as possible because it's energy. So the cooling leg works to an advantage there. Cornelius, I don't know, anything else you want to add to that? Oh, Cornelius, you there?
Sorry, I forgot to hit the unmute button.
Yeah, I'm not sure if there's anything you want to add to that.
No, not necessarily. I think it's a good explanation. It depends on the application. No, air vents high, traps low. That's generally the rule. There is another question here, but I think you might be handling that a little bit later. How do I select the correct trap size?
Yeah, so we will get to that later.
Okay.
So we'll hold off on that question for the moment. The other advantage I will add to the thermostatic traps as well is because they're what we call 3 draining. So they always drain away. And they're perfect for things like pharmaceutical applications. So there's no condensate sat there where bacteria can grow. So I will move on. So the biometallic steam trap. So it's similar to the capsule trap, but it works by metal expansion rather than vapor expansion. And let's see if I can get this video to play properly. So as you can see, as the condensate heats up, it moves up and it expands the metal. So effectively the expansion of the metal then, the expansion of the metal then closes the trap. As it cools, then they shrink again, it opens it. So it's as simple as that. It's effectively 2 pieces of metal that expand at different rates, allowing you to open and close the trap. So as we show here, open, where it's effectively they're both flat, they haven't moved. The expansion, where it creates this kind of shape here, the bow, which closes the trap, and that's a closed position. So the advantages and disadvantages of thermostatic traps. So again, they're good at air venting. Sustainably subcools condensate. So the advantage is, as we spoke before with the previous one, reduces flash steam for the same reason. Discharge temperature is adjustment. Yeah, to a certain degree, you can change the temperature of the condensate that's flowing out of it by the difference in the biometallic pack you use. And the valve clack acts as a check valve. Disadvantages, waterlogging, as we said before, very long cooling legs. So these require a longer cooling leg than the previous trap. Slow response to load change. So yes, they tend to work best where you have a constant load. And discharge temperature is affected by back pressure. Do we have any questions on thermostatic steam traps?
Yes, well, again, steam traps in general more, I would say, but what if the line is more than 100 meters long? Is there a minimum distance needed between traps, or do you need to install where there's a change in vertical direction? I think you will handle that a little bit later as well.
Yeah, I'm not sure if we touch on that in this one because I think we spoke on the installation one, but just as a general rule, we recommend steam traps every 30 to 50 meters. So if you've got a steam line that's 100 meters long, so you would need at least sort of 3 trap sets, maybe 2.
Okay.
The more steam traps you put in, as long as you don't put them every 10 meters, the drier, the more usable your steam is going to be. So yes, as we said, every 30 to 50 meters.
Yeah, and also just to add to that, as the question says, what about vertical distance or vertical direction changes? And absolutely, every time you have a vertical direction change, you would like to, this is an ideal opportunity to remove a lot of condensate, especially when it, after shutdown and so on. And those are also an ideal place. Those are also ideally places actually to add air vents at the top of that end of line arrangement. So, yeah. Very
much so, because a normal steam mains, for instance, you should have a drop in 1 in 100. So for every 100 meters, it will drop 1 meter. That allows you to have the runoff of the condensate into where Cornelius was talking, the bottom end of a lift. So it allows you to collect a lot of condensate there and remove it quite quickly. Any other questions?
That's it for now.
Okay. So liquid expansion steam traps. So this is what we call our number 8 trap. It's kind of a cigar. It looks like a cigar. So I don't think I have a video on this one, but effectively how it works is that you have this area here that expands when it gets hot. So it then moves up and closes the trap. And then you've got the condensate that flows out. This is a horizontally installed trap. There is no vertical version of this. These are great in the place of when you've got startup and shutdown. Startup, you would effectively open all the valves on your system on your drain points and then slowly close them as the steam system warms up. You could put this in place of that drain valve, and then this would close at 100 degrees. So it's already removed all the condensate. These are adjustable between 60 and 100 degrees. So it would save you having to manually close all the valves on your system on startup. They dump quite a lot. It's an oil-filled element, so it's quite robust. But yeah, it can remove quite large quantities of air as well and cold condensate. So perfect for startup, as we said. So before I move on to thermodynamics, is there any questions on the liquid expansion?
Not necessarily the liquid expansion, but there is a question about the difference between the AV13 and the BT13. I'm presuming it's a BT13.
Yeah, so the AV is an air vent, so that's why it's AV. They're technically the same sort of thing. It's just more the usage. So the BPT is designed as a steam trap rather than an air vent. But internally they would look very similar. It's mostly the position that they're designed to be at. An air vent will be at the top of a system, a trap will be at the bottom.
Yeah, the internals are the same, yes.
Yeah. So it's I think the BPT as well is horizontal ported, isn't it? Whereas the AV is angle ported.
Yes, it's a 90-degree angle on the air vent.
Yeah, so it's just where they're intended for install, that's all. So thermodynamic traps.
Sorry, just hang on.
Yeah, no, go on.
There is another few questions. Will the documentation and presentation be shared with the attendees? If you fill in afterwards for everyone, if you fill in the sheet and make a comment that you would like a copy of this presentation, we will share that with you.
Yeah, that's no problem. Yeah, we can make available any of the trainings we've done. The only thing we need is that last sheet gives us your contact details as well, so that we can actually send it to you.
Sure.
Any other questions?
Not yet.
Okay. So the thermodynamic trap. So this does have a nice video for you. So here you go. So as it shows here, as the condensate warms up, it raises it works on effectively velocity coming under the trap. So the faster it comes here, you get a pressure drop, which sucks or pulls down the disc, which then closes the trap. When you have water, you don't have that difference in pressure, so it lifts and then allows it the bleed of condensate. So the incoming pressure raises the disc, and condensate discharge from the inner ring under the disc and out through, depending on the version, you have 2 or 3 orifices. And hot condensate then flows, and then you get like we were saying, we get the drop in pressure, which closes the trap. So thermodynamic steam traps, advantages and disadvantage. So they are robust. There's not really anything that can crush or be distorted on them. So it makes them very robust, very able to cope with water hammer and various other things in your system. Can withstand superheat, so it doesn't really distort with any superheat. Resistant to freezing and water hammer. So as we said about water hammer, but freezing too. So if a trap freezes, it will stop working, but when it defreezes or when it defrosts even, sorry, it will still be in good working order. Wide pressure range on these, so they go up quite high. Compact and lightweight, so again, these are the small. Resistant to corrosion. The components in them, I believe, are mostly stainless steel and will work on any plane. So it's saying yeah, so I would recommend most of these are horizontal, just because of the position that the disc falls into. Disadvantages: can air bind. Yeah, so air can get trapped in there and stop this trap from working. And because of their size and the orifices that they have, they are relatively low capacity. We will cover where they're perfect to use though. Any questions on thermodynamic traps?
Just to add to what you just said, just a comment from my side, and there is a question. So the comment is, if you do install these in a vertical plane, they will work. Their life would probably be reduced a bit because the disc tends to wear off on the one side because of gravity, really. So it does wear a little bit more on the bottom side. And the question was, what are the importance of air vents in a steam line? I think we covered this in a previous session, but it might be worth just running through that again, because air vents and steam traps both remove barriers to heat transfer.
Yeah, so air is a barrier to heat. So effectively, it acts as an insulator when you're trying to transfer the heat from your steam into your process. So you want to remove it as much as possible. The other challenge when you say things like autoclaves or any kind of oven or sterilizing system is they will give you a false reading of temperature effectively, because the temperature pressure relationship isn't the same as steam. You can have a pressure which is 10 bar but not a temperature that reflects that. So you want to be able to remove as much steam as possible so that you can maintain the temperature you require for cooking or for process, but also so the transfer of heat is more efficient. There's no barrier in there. You also have the added issue of when air binds with condensate, you get carbonic acid, so then you have more corrosion, erosion in your system. Hopefully that kind of covers that part. I don't know if there's anything you want to add to that, Cornelius.
No, that's fine. There is another question. What's the best type to use on a condensate recovery line, especially when recovery line has no pumps? Again, I guess we'll get to that a little bit later when we come to the applications.
Yeah, so we will cover the applications in the slides, and we'll show which ones is your primary and your secondary choice. Again, it's a little bit to do with your installation itself, but yeah, we will show it.
Yeah, like for main lines, for example, if that's the question, it might be, if it's for a main line, then we would generally recommend thermodynamic steam traps. They are robust. They can handle a lot of the water hammer. They are quite tough. and they're quite small as well, so they don't, provided they're installed properly in a proper drop pocket.
Yeah, exactly. Okay, any other questions?
No, that's it. You can carry on.
Okay, so I'm just looking good on time so far. So quick fit, we do a version where you can quick fit traps. So as we show here, this trap here, you have the quick connection here. This they have a built-in check valve, I believe, so you can hot swap. These are very good where you want to speed up maintenance, so you have many traps, so you want to. The disadvantages on these will be they are lower capacity, but we have these options available too.
Yeah, we have just released on the float trap the UFT14 HC, the high capacity one, so it can discharge quite a lot more condensate, and these are very simple. If you have a critical plant to run and critical processes you cannot afford to shut down, it'll take you literally 5 minutes to replace the steam trap without any welding or cutting or grinding or hot work or any of those sort of things required. You can do it very quickly and very easily, and you don't need to be a qualified welder or anything like that to facilitate the repair.
Yeah, there's literally just 2 bolts here, so you just undo those, pop it off, pop the new one on, make sure you change the washers that are in there so you keep the seal, and it's good to go. Yeah, so as Cornelia said, 5-minute job. So orifice traps, fixed orifice traps. So we don't actually sell these, but we do cover them in the training. So it's an alternative to a steam trap. The install of these is relatively easy. They work by having a reduced orifice, so a small orifice plate that's in there, so it's effectively trapping it there. These devices contain a hole at a predetermined diameter, which is worked out by your process, and so it allows calculated amount of condensate to flow through it. So these will always be open. So they're designed for one set of conditions. So they work very well where you have a constant load. They're unable to handle load fluctuations, as we said. So because they are designed, the size of that orifice is designed for specific conditions. So if that changes in any kind of way, they don't handle it very well. So as you can see here, startup load, they're very good at removing air, as you can see here. So because you have the open orifice at all the times, the air is coming out. The challenge is that you will lose steam constantly through these as well. So they are, there's something we don't recommend because the job is to keep as much steam in your steam system as possible. Having an open orifice, although it works by the critical pressure drop and trying to keep the steam in the system that way, it will still leak, it will still pass steam. So it's a loss, which means that you're losing money through your trap. Any of you guys, so it's not a two-way conversation, but I would be curious to know how many of these orifice traps are in East Africa, really. In Africa in general, yeah.
Nick, and the other thing with these is that if they are slightly oversized, like what you show in that diagram there, then you will lose steam. But we've also seen that because the orifice is very small, they do sometimes tend to clog up, especially if you don't have a strainer in front of it. And as that hole starts blocking up, you start condensate backing up, and then you have the same sort of issues as a failed closed steam trap, essentially. And that could cause things like water hammer, poor heat transfer, etc. So they could, you know, if you have too much condensate going through, they might not remove it all. If you have too little condensate going through, then you might start losing steam. But if the conditions are it's basically the Goldilocks of steam traps. If it's just right, then it'll work fine.
Yeah. So yeah, the lower the load, the more likely you are to see a blockage as well. Is there any other questions on this?
Not yet.
Okay. So as we put there, liable to block. Air venting capacity is poor. So they are always open, they will remove air. So do you only need a steam trap? So here we go. So a steam trap forms part of the equipment you require. So when you install a steam trap, you should have a system similar to this. So you have the isolation valve to be able to turn it off if you have any maintenance, a strainer to protect the trap. You can put steam trap monitoring in if you want digital, or if you want to be able to monitor the trap in any way without physically having to open it. A check valve to stop any backflow, and another isolation valve so you can close the system off. So that would be a trap set, and that's what we would suggest should be the equipment around all your steam traps. Any questions on that?
Not yet. I think this is a good diagram that shows everything. It's very seldom, just a comment from my side, that we actually see that steam trap monitoring. We are looking at various different options in terms of wireless steam trap monitoring, continuous monitoring. And continuous monitoring obviously becoming more and more important, especially when people start talking about their sustainability goals, sustainability targets, net zero, etc. Steam traps can actually have quite a big impact for plants with that.
Yeah, so the one other thing I will add with this drawing is the strainer is actually the wrong orientation on it. So
yes.
on a condensate line, you should have the strainer pointing downwards, not sideways. The strainer sideways would be for a steam line, and it's all to do with on a steam line, you wouldn't want the collection point of condensate to be able to increase the chances of water hammer. Whereas a steam trap is a full pipe of water anyway, or condensate, so you would have it facing downwards to capture the dirt.
Yeah. So just one of the questions again, what is the best type to use on a condensate recovery line, especially when the recovery line has no pumps? Well, in a case like this, what you're seeing in front of you is probably from a process side, from a steam main line. You could probably use something like a thermodynamic trap, which is, because you need quite a lot of them in a larger installation, let's say more than 100 meters. It is a more cost-effective way of going for it is the thermodynamic. And if there's no pump and you want to send it directly back to the boiler house, that is fine, provided there is enough differential pressure across the steam trap.
Yeah. So you can do that by sort of manufacturing drops and whatever else, so you can get head pressure. But a large enough system, or a system above a certain size, I would suggest you're going to have to pump it some kind of way. The process trapping, as this would probably be, as Cornelius said as well, because you've got the FT14 or you've got the flow trap, it's allowing for a higher capacity of discharge. So it's near where end of line, effectively end of process, where you're removing the most condensate, and the smaller traps are designed more where they're beginning or middle of line, because there won't be so much to clear.
Yeah. Okay. Is there are you going to talk about the APT today, or are we only looking at steam traps? Because there is a question regarding APT.
So we won't be looking at APTs, because I was going to cover that in the next session, which is heat exchangers, but we can touch upon them today if you'd like.
Okay, because the question is there a steam trap that can work as a mechanical Ogden pump?
Yes, so we half answered it there. We have what we call the APT, which is our automatic pump trap. We also have a MFP, which is a mechanical pump trap, both of which use a motive steam connection. So you connect raw steam directly to a motive port. So when you receive a situation where the pressure downstream is higher or equal to the pressure upstream, the motive steam connection kicks in by seeing the ball float that has raised to a certain level, so it changes over mechanically. That then floods the compartment with steam, builds pressure, and clears the trap. So we do, as I said, it's the APT, the automatic pump trap, or the MFP, our mechanical pump trap. The APT is kind of a lower capacity than the MFP, but both of them clear quite a large amount of condensate. I think we're talking sort of 2,000 kilograms an hour or something like that on the MFP, certainly. I'm not too sure on the
depending
APT.
on the differential pressures and the back pressure.
Yeah. So we do mechanical traps. Any other questions?
No.
Okay. So we also do what we call the STS 17.2. So this is a complete trap station. So it has your isolation valves, your check valve, your steam trap, your strainer, all built into it. So as you can see here, your 2 isolation valves, trap is on the side there with the 2 bolts, your strainer is here, and sorry, yeah, strainer there? No, that's your check valve is
Check
there and your
valve.
strainer is here, yeah.
Mm.
We have different versions, so you have the UBP, so biometallic trap, you have the USM, which, what's the USM again, Cornelius? It's the biometallic trap, yes, sorry.
Metallic, yes.
Yeah, UFT, which is our float trap, UIB, which is our bucket trap, and UTD, which is our thermodynamic. All of these are going to be lower capacity than the individual items themselves, so the full mechanical ones, but 9 times out of 10, they do still cover the load that you require. Because they're all stainless steel as well, the wear on them is less, they're more robust, they last longer. So they are a higher cost, but they last longer. So there's the trade-off.
You also save quite a lot of money in terms of installation. But
Yes,
you don't,
yeah.
and you also reduce the potential leak paths, where if you have 5 separate items, you have 10 potential leak paths. Here you have 2 potential leak paths. And the other big advantage for me on this is, especially in cramped spaces, the shortest version I think is only 230 millimeters long. So that saves a tremendous amount of space on a plant where space is at a premium. So these are great, and like it says, they're made from stainless steel. They last a really, really long time. Many of our larger customers have gone over to these simply because of the ease of operation, ease of maintenance, and long life.
Yeah. We also do the double isolation versions of these as well, so they can be whatever your process requires. They, as Cornelius said, because they are one piece, there is less leak paths. So when we say leak paths, we just mean where you have a connection, a thread or a flange, there is potential for a leak. Because this is a manifold, there is no flanges other than the ends, so less leak paths. They're pretty robust. I mean, you would have to do a lot to damage one of these.
Yeah, and they're available in flanged, screwed, and socket weld.
Yes, they are. Yeah. Is there any questions on these?
No, we can carry on.
Okay, so as we said there, they're a quick connector for the traps. So as we showed before, very 5-minute job to change the trap. So I'm just going to skim through this a bit quickly, just because we covered that with the questions. So again, why so many different types of traps? So this is where we're going to look at the types of traps that you need to which best suit the applications you have. So optimum drainage performance as well. So we want to clear that condensate as quickly as possible by installing the correct type of trap. And optical mechanical performance. We want these to last a while. We don't want you to have to be replacing them before we would suggest. And venting performance, to remove that air as much as possible, because as we stated, it's a barrier to heat. And to cater for flash steam. So things to consider: the application, where are you going to install it? Upstream pressure and downstream pressure, so your pressure differential across the trap. Condensate load, how much condensate are you trying to clear? The materials required, and the connections you have. Risk of freezing, again, my slides are a little bit European, so in Africa there's probably not much chance of freezing. Maybe in South Africa you guys do have freezing temperatures at times. And water hammer risk. So as we show here, there's various different applications on the screen. As you can see, they have different types of traps. So we have a cooking vessel here, as you were saying. So because you want to get rid of as much condensate as possible for the heat transfer, this has a flow trap. Steam mains, which there's a couple of questions about. So you have a dirt pocket, and off that dirt pocket you would have a thermodynamic. And then you have things like a pressure reducing station. So again, you want to clear as much condensate as possible to protect this equipment. So you have another flow trap there. And on the end of a main line, so you have a balanced pressure air vent trap set. On this particular one, that looks like it's a fast connector, but it's probably a flow trap too. And your drain point. And an inverted bucket at times on process here too.
Just a quick one there,
Yep.
Nick. On one of the questions is, what isolation valves do you use? Globe valves, ball valves, or gate valves on steam traps?
So again, it's whatever your preference is. So we sell globe valves, we sell ball valves, both of which will do the job. So bellows seal valves as well. So if you take our BSA valve, that would be a wind up, wind down. Ball valves are quicker to isolate because they tend to be quarter turn. They're they're my preference, but they're not always suited. The challenge you have with a ball valve for isolation is if you have isolated, you have steam behind it, which is cooling and creating condensate. Because they quick open, because they're only quarter turn, if you're not careful, you have the chance of introducing a large slug of water to run straight down your system. With the bellows seal valves, because they're wind up and wind down, it's less likely. It can still happen, but it's less likely. Gate valves are kind of the tough version of any isolation valve because of the way they work, because the gate tends to be quite chunky. It's absolute isolation, but it tends to be for higher pressures. The bigger gate valves for bigger systems, DM300, DM400 and upwards, you probably find they have to be hydraulically moved. So that's an extra cost too.
Yeah, but it's probably not likely to have that on a steam trap set.
No, not unless you've got some serious usage. Yeah. I'm not sure if there's anything else you want to add to that as well, Cornelia.
That's, there's a few things to consider. One is, certainly in terms of ball valves, we find that the high temperature is something that do affect them. So if you are going to use a ball valve, just make sure that it can actually handle especially the upstream valve, can handle the temperatures. If it's 10 bar steam, that ball valve should be able to handle 184 degrees Celsius. That's often not, those become quite expensive. So then from a cost benefit ratio point of view, the small little globe valves or gate valves or whatever become a lot more cost effective then, because you'll be keeping on replacing that ball valve. So yeah, it depends. Look at the application, look at temperature, look at the pressure rating of the valve, and what's cost effective.
Yeah, I mean, a ball valve, for instance, gate valves as well, they use more material as well than BSA valves, bellows seal valves, so they are more expensive. Yeah, it's again, as Cornelius has said, it's process dependent, but it's also user preference too. So it's they all are good isolation valves, but just like anything in this world, they have advantages as well as disadvantages. So, any other questions?
No, we can carry on.
Yeah, so as you can see on the screen, so there is the trap selection here. So we have a booklet we can offer. I think we're definitely on PDF, where it will give you this list. So as you can see here, boiling pans. So you have fixed, tilted, and pedestral. So on a pedestal even, sorry. FT would be for your fixed. BP, so biometallic, for your tilting, and pedestal would be a BP2. An acceptable alternative we give here as well. So that was best choice, but you can use TD, BP, and FTCs. So the C is the anti-air bind version, I think. If we then go down to, say, hospital equipment, so autoclaves and sterilizers, which we spoke about briefly earlier. First choice would be a BP, so biometallic trap, but you can use a float trap. So we again, we can supply the PDF version of this, and it gives you an idea of the right usage. If you give your details and request it on the form in the end, we can supply you.
Yeah.
So just to kind of reiterate what we were saying before here, so steam mains, second choice would be a flow trap. primary choice would be the thermodynamics. Cornelius touched upon it earlier. It's to do with capacity, but it's also to do with cost. So thermodynamic trap is smaller, so it's cheaper. If you're using a lot of these, you don't want a massive expense of more materials, bigger traps and things like that. So thermodynamic is fine where you're not expected to see a high load. You're just trying to maintain a dry steam main. Space heating, so it's flipped here. So you can then see the flow trap. You want to clear as much as possible because you want as much heat as possible. Tanks and vats, first choice is a flow trap for similar reasons. Second choice can be a thermodynamic or even a balanced pressure. And tracing, so critical tracing where you need it clear, you need it whatever, we would recommend the thermodynamic because it's a blast trap, it gets rid of it quite quickly. And non-critical tracing would be balanced pressure. So that's where you want to kind of effectively get as much heat out of it as possible. Second choice, thermodynamic, and so on, as you can see with the other ones. So before we move on to diagnosis, is there any questions on trap selection?
No. I think they were asked earlier, and I think we've gone through that in a bit of detail now.
Okay, yeah. Again, if there's anything we speak on that you want more detail on, please get in contact with us afterwards. We love hearing from you guys. We can supply more information than we can do in these webinars because we have more time available. So any questions, any information you want, please get in touch. So consequences of failed steam traps. So if they fail open, it's a waste of energy. So therefore you're wasting money because you're losing steam. Increases production costs. So yeah, to run your process, because you've got those leakages, it's going to be more expensive. Plumes of steam visible. Us in the steam industry, we quite often have public around our buildings see steam and think it's smoke. So that normally ends up with a lot of complaints. There's also, as you can see, the steam. If you can see the steam venting, you are still losing money. Can cause problems in pipes, so with more erosion, corrosion, but the plant will still operate. Failed closed though, plant will waterlock, so you will have water hammer, you will have wetter steam, you will have carryover, all those things down into your process. Reduce plant output, you're just not seeing the heat that you require, so you will reduce your output. Spoiled product, so if you're cooking something and it's a critical temperature that you need, if you don't achieve process temperature or it takes longer, you could spoil the product and that will lead to wastage. Complaints of underheating, so again, as we just said, safety hazard, water hammer. So if you have this slug of water hitting down onto closed valves or traps, you can have a failure, and when they fail, they can crack. So if you take a cast iron trap, for instance, you could introduce microfracturing, and at some stage that trap will split open. And freezing again. So if it's a cooler trap and you have the conditions available, it's more likely to freeze.
Just a time check. We are on 2 minutes past 11.
Okay, yeah, so I don't think there's that many, I think, so I will rattle through the next one.
So 3 left, yeah.
Yeah. So again, we'll just make sure this is all on. So just as an example, so if you've got 12 kilograms of steam you're losing for a steam trap, that's 137 tons per year. And the cost on tons per year for CO2 emissions, so that's over £2,000 per year in fuel costs. So I know less in pounds. I think it's only me that works in pounds. But it could be excessive. It could be expensive for you guys.
About 40,000 Rand in South African Rand. So
yeah, so I think that would be about 100. So about just under 300,000 Kenyan shillings. So again, single and double sight glasses. They're not always reliable because they can get dirty. You can't see them properly, but they are a visual check on your steam system.
Yeah.
And I'm just saying, so again, this is just a little bit of what we can offer you. We can diagnose your traps. We can send an engineer to you guys. This is kind of how it works. So fully trained Spirax engineer to attend site. Steam trap condition is assessed. recommendations made based on your product type and application and installation. And then steam losses are calculated, so we can tell you how much money you're losing. A report is provided to you, so you can, along with a visit to site. And the results can be accessed via your SIMS web portal. So that will depend where you are in the world. I'm running through this quickly only because of the time. So this is the automatic steam monitoring system that Cornelius and I were speaking about earlier. You can put a sensor in, so it goes to an amplifier box. LM report sends it to wherever you want. So this is the rough equipment that you'd require. Again, if you have more questions, because we're speeding through this, please email us, message us, and we can give more detail. So that would be the end. It's Q&A now, so if there's any questions, again, I've left it on the slide that you can see there so that you can see the information we can offer. So we have the steam condensate loop books, the metric steam tables, there's other PDFs that we can supply to. And of course, our contact details if you would like to get in touch with us directly. Any questions there, Cornelius? Because I really rattled through those last ones.
No additional questions, Nick. And I want to just end off by saying thank you to everyone for, it's been really delightful spending time with everyone today. I think that, you know, there were a few things that you observed today in today's presentation that you might have made you think a little bit on site. Well, you know, perhaps we could change this, or perhaps we can get Spirex out to come and have a look at that. We'd be happy to accommodate you with that. Please just contact us at your earliest convenience, and we'll get someone out to come and assist you getting your plant as mechanically correct and appropriately maintained as possible. So thank you again from our side. And if there are no more questions, we will see everyone hopefully on the next webinar. Thank you so much, Nick, for your time as well.
Thank you very much, everyone. It is always a pleasure to present to you guys. So thank you for your time too.
All right. Thanks. Cheers.